Hi, welcome to the presentation on water supply defined terms. In the building code, they use terms like frequency of use and rate of supply to define the fixed unit that is used for the design of water distribution systems. Water supply fixed units represent the load that is allocated to various fixtures for sizing water piping systems. Potable means safe for human consumption. This code definition is the only term that makes reference to a level of safety for the occupants in the building. Expressions like toxic, non-toxic, and food safe are not terms defined by the code, nor is there any method described for determining levels of toxicity. Potability of water used for drinking in BC must meet the requirements of the Drinking Water Protection Act and Drinking Water Protection Regulation. The Provincial Health Authority's drinking water officers are responsible for providing oversight and ensuring compliance with water suppliers that deliver safe drinking water. The Groundwater Protection Regulation covers the design and installation of private wells in BC. Property owners are responsible for the safety of water from their source. Drinking water from private sources should be tested by a provincially approved testing agency. A private water supply system includes the entire assembly of equipment and devices that convey potable water from a private source to the water distribution system. Auxiliary water supplies include sources such as wells, springs, lakes, and rainwater tanks like this one. Only supply systems that meet the definition of potable can be used to supply a potable water system. Auxiliary water supplies can also be used as sources of non-potable water for uses such as irrigation or toilet flushing. Note that private or auxiliary water supplies can never be interconnected with a public system as per Article 2625. And suitable separation of such systems is paramount to health and safety. A water service pipe conveys water from a private or public water source to the inside of a building that it serves. Approved materials include piping such as Type L or K soft copper tubing, PEX, or Series 160 polyethylene. See Articles 2216, 2613, 2615, and 2634 for more information about water service pipe requirements. The water distribution system delivers water from the water service pipe to points of distribution throughout a building. Water distribution systems must be designed with good engineering practice, including both hot and cold water at sufficient flow pressures to satisfy the requirements of the building occupants. Fire service pipes convey water from a private or public water source to the inside of the building it serves to supply the fire protection system. A riser is a water distribution pipe that passes through at least one full story. Risers must have a shutoff installed at their base unless they serve only one dwelling unit. Riser shutoff valves are specified in Article 2613, Sentence 3. Supply pipes convey water from the water distribution system to a single fixture or device. Although not a defined term, their minimum size is dictated in Table 2632A, as stated in Article 2634, Sentence 2. Welcome to the presentation on miscellaneous definitions. Air admittance valves are designed to prevent negative pressures from occurring in drainage systems. Approved valves must conform to ASSE Standard 1051, and their installation is limited to the conditions set forth in subsection 259 of the code. The most common application for an approved air admittance valve is for the venting of island fixtures, like this kitchen sink. While they are different in their location in plumbing systems, both air breaks and air gaps prevent reversal of flow and the subsequent contamination that may occur. Air gaps and air breaks are unobstructed, indirectly connected piping that play an important role in plumbing systems. Air breaks are never less than 1 inch or 25 millimeters in vertical distance and separate drainage systems where a backflow of waste would be unwanted or objectionable. Air breaks are a mandatory indirect connection and are required for certain fixtures and appliances, especially those which contain or process food. See Clause 24211E for a list of these devices. Air gaps are also never less than 25 millimeters in height and form part of effective cross-connection control. They are used to separate the potable water supply system from the sanitary drainage system. Air gaps are found at nearly every fixture that supplies water over the rim of a vessel. Where air gaps cannot be maintained, a vacuum breaker or similar device must be installed. Backflow is the unwanted reversal of flow in a piping system. Backflow is caused by one of two occurrences, either from back pressure or from back siphonage. Back pressure backflow is caused when the downstream pressure becomes higher than upstream pressure. Two examples would be the application of a booster pump or the expansion of water as it is heated. Back siphonage backflow is very common in systems that experience a sudden loss or reduction of supply pressure. Backflow preventers are devices, methods, or assemblies that are installed to inhibit reversal of flow in piping systems. They are placed at numerous points of distribution within plumbing networks. The picture on the left is a reduced pressure backflow assembly that is used to isolate high hazards from the potable water distribution system. The picture on the right is a hose connection vacuum breaker that is used to assist in preventing low hazards from being back siphoned through a hose. Vacuum breakers are a type of back siphonage preventer that must be installed where hose bibs are located, as per Article 2627. Other requirements for backflow preventers are contained in subsection 262 of the Code, titled Protection from Contamination. Backwater valves are installed to prevent reverse flow in a drainage system. They're especially useful when building drains are connected to sewers that are subject to backups, like combined systems. Requirements for backwater valves are found in Article 2464. Note that only normally open styles, like this one shown, can be installed on a main building drain in order to maintain the free flow of air within the drainage system. When a bathroom contains only one water closet, one lavatory, and one tub or shower, this assembly of fixtures is often simply termed a bathroom group. Common three-piece bathroom groups are intended to be used by a single occupant. Therefore, the hydraulic load assigned to a bathroom group of fixtures is often reduced by 1/2 fixture unit, to reflect the fact that it is rare for all three fixtures to be used simultaneously. Check valves are installed in piping systems to ensure direction of flow. These non-return valves have a disc and seat that will close when flow is reversed. Many check valves must be mounted in the correct orientation to be effective, and different styles are available for different applications. Some check valves have testable components to verify their operation. Cleanouts provide an access into drainage and venting systems for inspection and cleaning purposes. Their spacing and sizing must conform to Table 2472, and additional conditions are provided in subsection 247. The developed length of a piping system is the entire length of the system that is installed. For example, this illustration shows a piping offset that is 800 millimeters in height. However, if you were to measure along the center line of each piece installed, you would see that the actual developed length used to accomplish this entire offset is 1300 millimeters. Another way to consider developed length is that it includes all changes in the pipe's direction, both horizontal and vertical sections. This is an important term that is used to identify requirements such as the maximum permitted length of outlet pipes, as identified in Article 2482. Most fixtures are directly connected to a drainage system, meaning that their connections are sealed tight from gases and liquids. Occasionally, fixtures and equipment must be installed through indirect connections, like through an air brake. This picture shows the overflow from a rainwater harvesting system being indirectly connected to the storm drainage system so that backflow from the storm system cannot occur into the tank. Dwelling units are supplied with facilities for independent living, such as a kitchen, bathroom, and sleeping provisions. Rooms or occupancies defined as dwelling units must conform to the requirements as defined by the BC Building Code. Emergency floor drains protect property from water damage and are installed where overflows may occur. They impose no drainage load to a system, but must be vented unless installed in conformance with Sentence 25113. Field reviews are conducted for projects that require a building or plumbing permit. They identify issues at relevant stages of construction and provide feedback and consultation to the respective trades. Some storm drainage systems are designed to accept a certain design flow rate, which may be less than that of the local accumulation values. These systems control the flow of storm water to the rest of the management system, acting as a detention method, which has several benefits when designed properly. These systems are typically engineered as the extra weight of the designed water on the surface must be accommodated. Additional protocols are also found in sentence 2.4.10.4.2. Division A, Appendix A, shows an illustration that graphically explains the difference between what the code considers nominally horizontal and nominally vertical. Piping installed at any angle less than 45 degrees from horizontal is named as horizontal for the purpose of code application. Therefore, any slope on piping that is up to an angle of 44 degrees from level is still considered to be a nominally horizontal installation. When an installation is vertical, or up to and including 45 degrees, the code identifies this as nominally vertical, or in other words, as good as vertical. Solar waste pipes that are installed nominally horizontal are usually designed to be filled to no more than 2/3 full of liquid, whereas piping installed nominally vertical is typically designed to flow with 1/3 liquid and 2/3 air due to the increased velocities. Offsets connect the ends of two pipes that are parallel. Generally, an offset changes the pipe's path while traveling along the same plane. Private use and public use are terms used in plumbing design to determine loading for DWV and water supply systems. Private use refers to fixtures that are restricted to the operation of a single family or occupant. Single family dwellings would contain private use fixtures, for example. Public use fixtures are not restricted to their access. These types of fixtures would be found in shopping malls, food courts, schools, stadiums, and other public facilities. In a hotel, the washroom fixtures in the lobby would be considered public use, while the washrooms in the private suites would be private use. Flow-through type fire protection systems are typically constructed of PEX tubing and other potable related components. Their installation is intended to be integrated into the domestic water system for simplicity. Partial flow-through arrangements may introduce bacteria to the remainder of a water system. Full flow-through systems, however, are designed to ensure that water moves through all parts of the piping network when fixtures are operated. Surface water heaters are used to heat water for a variety of domestic purposes. Storage-type water heaters are probably better known just as hot water tanks. The water temperature is maintained by a thermostat, and they typically hold the capacity of water that is stored for future use. Direct-fired types have an energy source installed at the tank that directly heats the water with electric elements, a gas burner, or condenser unit. Indirect tanks are heated by a secondary heating fluid in conjunction with a heat exchanger that is either immersed in the tank or external to the tank. Non-storage type or tankless water heaters heat water basically on demand. They require less space due to the fact that they don't utilize a storage tank, although they can be used in conjunction with external storage. These types of heaters are usually wall-mounted and typically gas-fired. Plumbing stories are any level in a building that contains plumbing fixtures, including mezzanines or other intermediate levels. Traps are liquid seals that prevent entry of sewer gases into buildings. To ensure the liquid seal is protected, venting is installed to keep pressures in the system neutral. Trap requirements, contained in Article 2231, state that traps must have a seal depth of at least 38 millimeters, or 1.5 inches. The trap seal depth is determined from the difference in height between the trap's dip and its weir. The weir establishes the maximum amount of liquid that a trap can maintain. Some traps may also need replenishment to maintain their seal. See subsection 245 of the code for more requirements regarding traps. This picture shows two common styles of ABS plastic traps. On the right, the hub-by-hub style glued plastic trap is ideal for locations that are typically inaccessible, like for tubs and showers. Notice the union trap on the left. It allows the trap to be removed for cleaning purposes, for lavatories, sinks, and laundry trays, as required by sentence 22313. Another acceptable solution is to provide a cleanout plug at the lowest point of the trap. Trap standards, like this one shown in the left illustration, have a built-in support, as they're integral to the support for certain fixtures. This P-trap standard would be used for some types of wall-mounted mop sinks. An S-trap standard is the name sometimes used in the description of a water closet's trapway. S-traps are not permitted on fixtures as they will self-siphon. However, water closets are designed for self-siphonage to evacuate their contents and have a built-in fill valve to replenish their trap seal and tank levels.